We're going to continue in this example to do some more probability tree questions. So our question here that we're asked is, Amos travels to school either by car or by bicycle. The probability of being late for school is 1 over 10 if he travels by car and 1 over 15 if he travels by bicycle. On any particular day, he is equally likely to travel by car or by bicycle. And we're asked 3 questions about this. We're asked for a probability tree. And then we're going to find the probability of taking the car and being late. And then we're going to find the probability of being late. Finally, we're going to find the probability of riding the bike given that, and so this will be new, he was already late. So we know he's late. What was the probability that he had the bike? So we're going to start though with the probability tree, and we're going to label our events as such. Car is going to be C, bicycle is going to be B, and late, well, late will be either late or not late. So of course, not late is not late. All right, so we start our tree. We need to say we have 2 choices. He needs to get to school, so it says both are equally likely. That's important here. Equally likely between 2 options means a 50% chance of both, or 1 over 2, or 0.5. So the probability that he took his car to school is 0.5, and the probability that he took his bike to school is 0.5. That comes from the equally likely. Now we need to say, okay, well, is he late or not late? So our next branch is going to be, if he took his car, was he late or was he not late? So the probability of late here, probability of being late is 1 over 10 if he travels by car. So probability of late is 1 over 10, which is 0.1, which means the probability of not late, and since we know the branches all have to add up to 1, this is 0.9. And now we have to say, okay, let's say he took his bike. If he drove his bike, what's the probability that he was late? And we see that's 1 over 5 if he travels by bicycle, so that's 0.2. And then the probability of not late, well, that's everything else, 0.8. Alright, so there's our probability tree for this situation. Amos first needs to decide what's he going to drive to school, and then is he late or not late, late or not late. And we're asked to find, in part A, or part B, the probability of taking the car and being late. And so this should just be a simple multiplication. We look at our tree. Probability of taking the car is 0.5. The probability of being late, so now we're at this branch over here, 0.1 when he takes the car. And that gives us 0.05. Next, we have the probability of being late. So there's 2 times he can be late. So that can be the probability of taking the car and being late, plus the probability of taking his bike and being late. And in this example then, that means that's the probability of car times late. Well, we won't write that because we just calculated this, didn't we? We can just say this is 0.05 from the line before. We just did that question. Plus probability of bike and late, well, bike is 0.5. Late if he takes the bike is 0.2. Multiply and add, we get 0.15. So that's the probability of being late, irrespective of if he takes the car or the bike. Finally, we're asked, in part D now, this was C and B, the probability of taking his bike given that he showed up late. So Amos shows up late to class. We know he's late. If we had to guess if he had his bike or car, well, we can estimate how often he would have his bike in this situation. So what we're looking for is the probability that he rode his bike now that we know he's late. So we did a formula for this already. This is the probability of B and L divided by the probability of B. So B and L, so that's rode his bike and was late. We just did that right here. That was 0.1. Probability of taking his bike, well, that was 0.5. So the probability, oh, and I got that backwards. I knew that wasn't making any sense. What I have a calculation here for is probability of bike and late given that he took his bike, but that's not what we want. We want given that he was late. So we're dividing by 0.15. Right? Because this here was the probability of being late. And that means the answer is 0.67, or 6 repeating. So if he's late, we know he's late, there's a 0.67 probability, or a 67% chance that he rode his bike that particular day. So that's all the questions for that example. Continue to the next videos to see the solutions to the other questions.